Hi, let's define direction angles of a vector. If I'm starting with a vector A that has the components A1, A2, A3, and I want to define this vector in terms of its angles. When I say angles, I mean the angles seen in figure, which are the angles alpha, beta, and gamma. Let's define each one of these angles. Okay, the alpha, beta, and gamma, where alpha actually is the angle between the vector that of concern lower A and the x-axis described by the unit vector along the x-axis I. Okay. Also, beta will be the angle between the vector and the y-axis, which we will represent by the unit vector j, and gamma will be the angle between A and the unit vector in the direction of k. Okay. Now, these three angles actually defines my vector. That's why we call them direction angles. If I know alpha, beta, gamma, then I have my vector completely. My vector is defined completely, okay? Or the direction of my vector is defined completely. Let's now get the relation between the vector A and these angles. First of all, we recall from the dot product, the dot product of between two vectors A dot B is the given by the definition, of the geometric definition, magnitude A magnitude B times cosine the angle theta, where we said that this theta is the angle between the two vectors and it ranges from 0 to pi. Okay, I want to use this definition in our case. In our case, if I consider this vector B, if I consider this vector B to be the I vector, مثلا, then this formula actually will be A dot I, which is equal to magnitude A, magnitude I, which is a 1, if you cosine the angle between A and I, which is the alpha. So you have here cosine alpha, which is A dot I over magnitude A. Now I need to simplify more. I know that this I is the vector defined by the components 1, 0, 0, okay? If I do dot product till A with this I, now I have this, I'll multiply A1 times 1, plus A2 times 0 plus A3 times 0, which I'll end up with A1 over magnitude of A, okay? But this is the formula for the angle alpha. Similarly, in the same way, if I took this B vector to be the J, then I would arrive at the angle between A and J, which is in the figure, I named it beta. But cosine beta actually will be the second component A2 على magnitude of the vector A. And also if B is if I took the vector B, which should be K, يبقى معايا cosine the gamma angle between A and the Z axis, which will give me the third component A3 over A. يبقى now I could rewrite my vector A in terms of these cosine angles. That's why we call it a direction angles, out direction cosines, okay? So the vector in terms of the direction cosines, actually the vector A1, A2, A3 from the above relations, actually it is the magnitude of the vector A. This is a scalar, this is the magnitude of the vector, okay? Times the vector actually defined by the components where A1 is cosine alpha times magnitude A, and I took magnitude A common برا as a scalar, and then عندك a cosine beta, and the last component will be cosine I. That's why we call these direction cosines also, because they show up in my vector as cosine the angles, okay? So the next thing, now I know that my vector is composed a bit magnitude and vector or direction, so that I know that my magnitude is still is A. I know that, yeah, but I need to verify that the length of this direction of this vector actually is equal to 1. Yeah, but we know that the length of a vector, I'm going to take a square of the components, يعني cosine squared alpha plus cosine squared gamma beta plus cosine squared gamma under the square root, and I want to check whether it is equal to 1 or no. Okay, this will let me arrive at the next important identity that relates these cosine angles with each other, أو يعني direction cosines with each other, and gives me, it is yes a unity, as if I'm squaring the length. If I squared, I'll get 1 squared. If I want to prove that the vector has unity length. So proving, actually I'll go back to the same analysis. I know from above that cosine alpha actually is a1 over the magnitude a, and so on. كده cosine beta is a2 على magnitude a. If I squared, يبقى I'm gonna get a1 squared, squaring by both sides, يبقى cosine squared is a1 squared على magnitude a squared, and so on. Similarly with cosine squared beta and cosine squared gamma. Substituting these in the formula in the identity, and I'll start with the left hand side and substituting. Cosine squared is a1 squared or magnitude ao squared. Cosine squared beta is the second component squared magnitude a squared. The cosine squared gamma is the third component squared magnitude squared. Simplifying, taking one of the magnitude a squared as common, I'll end up with a1 squared, a2 squared, and plus a3 squared, which is definitely, this is the magnitude of vector a squared without the square root. So I'll end up with cancellation, and I have my 1. Yes, this is a unit vector of my direction, and I call it the direction cosines. Okay. To solve مثلا an example, say I have need to find the angle between a vector a, okay, and the z-axis, given that I know that the angle between the vector and the x-axis and the y-axis is pi over 3 and pi over 3 respectively. Okay, so when I say this, actually it's a relation between the direction angles. I notice here that the x-axis makes the angle pi over 3, this is my alpha, and the y-axis makes the angle pi over 3, then this will be my beta, and the angle that is required to find between the z-axis, which we called previously in our analysis gamma, and this is the unknown. يبقى now I have two parameters or two values in this formula. It is a function of alpha, beta, gamma. If I have two of them, I could find the other. But definitely I could directly substitute over there. In this identity, I'm gonna get cosine squared pi over 3 plus cosine squared pi over 3 plus cosine squared gamma equals to 1, which will end us with, we know from trigonometry that the cosine angle 60 is half, so the cosine squared is 1 over 4 plus 1 over 4 plus cosine squared gamma equal 1. Yani cosine squared gamma is equal to 1 minus half, which is a half. Yani cosine gamma actually is 1 over square root. Bordo, I know this from our trigonometric relations, that this means that the angle gamma is the angle pi over 4. Okay, so my